So, we are today playing with chapter 6. Come on. Chapter 6, section 1. And the title of this particular section is Operations on Functions. Now, I do want to make sure that everyone understands function notation. Okay, I need everything to move. Everything to move. Woo! This is going to be a long day. Seriously. You know what? Forget it. We'll just deal with it as it goes. Okay. So, functions. The f of x. What does that mean? It is another version of y, right? We could indeed replace f of x with y, right? That's true. What else does f of x tell me? Yeah. It's a function, right? F of x is function notation, right? And it tells me that everything that follows is a function, behaves like a function, follows all the rules of functions. So all those things that we've been learning about transformations, all the things that you learn about when you move into calculus and pre-calculus, all those rules will still follow, all right? So functions are kind of a big deal. Now, g of x, what does it mean? Yeah.
It's not.
Nope.
The same thing.
Yeah. It's the same thing. It's just a different letter, right? So the fact that we went from f to g just allows me to talk about a different function, right? So I could say plug 2 into g of x, and you would plug it into the correct one, the 2x plus 1, as opposed to plugging it into the other one, right? This allows us to talk about more than one function at a time. Does that make sense? So the letter doesn't change anything. It just means that we have a different function. So far, so good? Okay, let's see if we remember some function substitution.
I just found a trigger on my neck.
I'm sorry to hear that. F of negative 2. What does that mean? Yeah. Plug in negative 2 for x. So I go to f of x, and I replace the x with negative 2. So I will get negative 2, the quantity squared, minus 4.
Call somebody up here.
Okay, we'll do. All right, so negative 2 squared is 4. And then 4 minus 4 is?
0.
Woo! So we get 4 minus 4, which gives me our final answer of 0. Does that make sense?
Yes.
Yes, ma'am.
This says, oh wait, no.
What?
I thought it was saying negative 2 equals 0.
No. I am saying that f of negative 2 is equal to 0. So we have to make sure that we understand the difference there. One thing to make sure that you pay attention to, I don't expect anyone to do this in this particular class, but I know that in Algebra 1 it happens. Don't divide both sides by negative 2. Right? We're not solving for f, right? So you don't need to do anything over here, right? This is just fancy substitution telling me to plug in the negative 2. This side stays exactly the same. Does that make sense? Okay. All right, what about g of 5? What's that telling me? Yes? Plug in 5 for x and g, right? And so that gets me 2 times 5, and then plus 1. 2 times 5 is 10, and then 10 plus 1 is 11. Yay! Good. Congratulations. Yeah, that's all we're doing. No, that's it. That's it. Yeah, no. No, this goes on. This goes on. All right. Let's try a slightly different problem. can someone tell me what to do with f of w? Plug w in for x. Basically, we just changed variables, right? So nothing spectacular here happens. We just wind up with w squared minus 4. Right? Make sense?
Is that the answer?
Yeah, that's it. There's nothing else to do. Like, I don't have a value for w. This isn't equal to something else so that I can then go through and solve and find a value. This is literally just replacing x with w. Right?
X is equal to W.
So, g of y minus 5. What's that telling me to do? Plug in y minus 5 for x. And so I get the new problem, 2 times y minus 5, and then plus 1. And now we simplify, right? Distribute the 2 to get 2y minus 10 plus 1. And we get 2y minus 9. Yes, no? We good? Okay. Let's make things slightly more interesting.
Oh no, interesting.
All right. We're going to keep the same functions. In fact, I'm going to go ahead and rewrite those functions here above our current spot. If you want to, you can do that again, but we're going to stick with the same two equations. So if you just want to refer back up to the top, that's fine too. Remember that that's supposed to be an f. F of x is equal to x squared minus 4, and that g of x is equal to 2x plus 1. Okay? So, what do we got? What do you think this particular thing here, f plus g of x, is telling me to do? What do you think? Yeah. Add the two equations together. So it literally means to take f of x and add g of x, which means that I am simply taking x squared minus 4 and adding 2x plus 1. So from here, I'm combining like terms, right? What's my final answer for this? Yeah. X squared plus 2x minus 3. Yes, no?
Yes.
We good so far? Okay. Let's try another one. What do we think this one means? We subtract. And so we have f of x minus g of x, which when we do our substitution is going to give me x squared minus 4 and then minus 2x plus 1. Now, of course, here I'm going to have to what?
Change all the
Distribute the negative or change all the signs, depending on how you prefer to look at it, right? So I'm going to go ahead and rewrite. And so I get x squared minus 4. Distributing the negative gives me minus 2x and a minus 1, which means that my final answer is x squared minus 2x and then minus 5. Yes? No?
Yeah.
We good so far? Okay, let's try another one. What about this one? What do we got? Yeah, we're basically just going to multiply the two together, right? Okay. Say again. All right. So this one, of course, literally just means that we take f of x and we multiply g of x, which will give me x squared minus 4 times 2x plus 1. We'll double distribute here, giving me 2x to the third plus x squared minus 8x and minus 4. Do I have any like terms? Nope. So we're done. So far, so good? Excellent. Lumos. Oh, where'd it go? There it is. Oh, that's unfortunate. All right. Put some stuff too far apart and other things too close together. What's this one? Dividing. All right, so this one is, again, literally just putting f of x over g of x, which in this case gives me x squared minus 4 over 2x plus 1. What would I do at this point? Say it louder. Simplify, right? I would try to factor and see if anything will cancel out. Does anything cancel out here? No. The top does factor. It factors into what? X plus 2 and x minus 2, right? But nothing will cancel out. So that's our answer. We're done. Okay, so far so good? Okay, this is where things get fun. This is where things start getting fun.
It's pretty foggy.
So we do tend to call this section fog and goff,
Oh, no.
but that's not a no. Okay? This is what we refer to as a composite function. Okay? We call this a composite function. So, what do you think that means? If I call this a composite function, what do you think we're talking about here? Yeah. It's not an inequality. That was a good thought, though. I like where your head went.
Is it f of g and then of x?
Oh, look at you.
Oh no.
Yes. It is f of g of x.
Oh, that's so fun.
What is the root to the word composite? Compose. So the word composite basically means to make up of other things. Okay, so a composite number is a number made up of other numbers, right? I can multiply 2 times 4 to get 8. So 8 is composed of 2 times 4, right? As opposed to prime, which is only composed of 1 and whatever that number is, right? So a composite function is a function that is made up of other functions. Yes?
It's like the log button on your calculator, is that L of g?
No. But that was a great thought. The log button on your calculator is chapter 7.
Oh.
I can't wait till chapter 7. I love chapter 7. All right.
That's the next one we're gonna do.
That is, after this test, we do hit chapter 7. If you throw up on my desk, you have to clean it up. All right, here we go. So, this is still just a game of substitution, right? Start from the inside out. G of x. Does g of x have a value? What is it? It's 2x plus 1. So I'm going to replace g of x with what g of x is. And g of x is 2x plus 1. Now, what does that mean? F of 2x plus 1. What does that mean?
We have to put it in the other one.
We go to x squared minus 4 and we plug it in. Wherever there's an x, we replace it with 2x plus 1. So, we start to get the following. 2x plus 1, the quantity squared, minus 4. Now, 2x plus 1, the quantity squared, when we do that multiplication, we wind up with 4x squared plus 4x plus 1, and then minus 4. And when we finish this off, we get 4x squared plus 4x, and then minus 3. Make sense? Not bad, right? Now we can also go the other way, right? So instead of fog, we have guff.
Golf without the L.
Yeah. So in this time, we are, this by the way is read G composed of F, is how that is actually spoken out loud, right? G composed of F, and then of X. But I tend to just call it G of F of X. I find that to be an easier way to talk about these. So G composed of F of X means that I'm going to take out the F of X and replace it with X squared minus 4. And G of X squared minus 4 means that I will be taking out the X and replacing it with X squared minus 4. So I have 2 times X squared minus 4 and then plus 1. We distribute and then add the 1 to get 2x squared minus 7. We good? Yeah, it's not bad, right? This does, however, because we are like substituting functions into functions, this does tend to throw off some people. It gives them a little bit of a head spin. Yes?
I don't know if I'm like getting far ahead, but that X, can you like change that to be like a number of 3 or like?
You can. Right? I can, instead of having g of f of x, I could have g of f of 3.
Oh.
In which case I would find the value of g of 3, then take that number and plug it into, I would find f of 3, and then take that value and plug it into g, and I'd get my answer.
Huh.
So,
That's crazy.
yep. All right. Slightly new type of problem. I've got 2 functions, each made up of just a series of ordered pairs. Take a second, copy that down.
That would have been scary.
So f of 9 we said gave us 13, right? So this is 8 and 11. This is 5 and 8. This is 10 and 9. And then 9 and 13. Whoa.
Just like goodbye.
Nope. I
I'll be on camera.
love this program. Really, I do.
We should leave this all on camera. It's the best part.
Seriously. Okay. Well, we're going to move on because I'm not, well, I don't know that I can move on because I can't scroll down. All right. So,
That would've been scary.
So f of 9 we said gave us 13, right? So this is 8 and 11. This is 5 and 8. This is 10 and 9. And then 9 and 13. Whoa.
You're just like goodbye.
Nope. I
It's all be on camera.
love this program. Really, I do.
We should leave this all on camera. It's the best part.
Seriously. Okay. Well, we're going to move on because I'm not. Well, I don't know that I can move on because I can't scroll down. All right. So,